Right, a horizontal cylindrical tank has a cross-sectional area of that at height x meters above the bottom. So, okay, a horizontal cylindrical tank. So I guess they're meaning like this. Has a cross-sectional area like that at height x meters above the bottom when x is less than or equal to 3. So, is that what they mean? The volume between heights A and B is that integration. Okay, well, I guess I don't have to worry too much about the diagram because the first thing is just integration. Find the volume at heights between 2 and 3. Again, there should be a non-breaking space here between the 2 and the meters. 2 and 3 for 6x minus x squared dx. So that is integration 2 and 3, 24x minus 4x squared dx. So that is 12x squared minus 4 over 3x cubed, 2 and 3. So let's see what I get here on the calculator. That's 104 over 3 meters cubed. B. Suppose that oil is being pumped into the tank at a rate of 50 liters a minute. Use the chain rule. At how many meters per minute is the height of the oil in the tank changing, expressed in terms of x when the height is at x meters? Okay, so let me just calculate. Oh, we don't have a formula for volume. I should calculate that, shouldn't I? So we want suppose that oil is being pumped in the tank at a rate of 50 liters a minute. So that means dV dt is 50 liters a minute. So that takes care of that. And use the chain rule. At how many meters per minute is the height of the oil in the tank changing, expressed in terms of x? So that's the dx dt. So what we need is a dx dv. So we need a v. Now, I'm not actually sure what way the picture is set up here, but if this is a cross-sectional area, I can't, I mean, I think I can say that the volume at x should be the integration from 0 to x, and I want to use a different letter so not to confuse things, for 6y minus y squared dy. So that would equal 12x squared minus 4 over 3x cubed. So that's the volume. So then the area, then dv dx is 24x minus 4x squared, which is the area. So then that means dx dt will be the reciprocal. So that's 1 over 24x minus 4x squared times the 50. How long does it, I think that's right. How long does it take to fill the tank, the 3 meters, starting from a fill level of 2? Well, that would just be 104 over 3 divided by. Now, oh, actually, I guess we have to be a little bit careful here because we're using meters and here is liters. So actually, I should say that's 50. I should use meters. So that'd be 50 over 1,000 meters cubed. So I'll divide that by 1,000. So that should just be that divided by 1,000. Yeah, okay. 104 divided by 3 divided by that. That is 693 and a third minutes. 50 liters a minute is pretty slow. That means it takes 20 minutes to fill up a meter cubed. And we have like 33 meter cubed. So yeah, that seems about right. I'm not sure about this question. I just wish there was a diagram. Oh, well, I think I'll just leave it there because then the next question is switches to is some data processing stuff.